All right, here's a systems of equations test review. Ready for the test. First two, they want us to solve using the elimination method. Remember, the elimination method is getting rid of one of them, trying to make it match. If I take a look at the first one, 3x plus 2y equals 10. I have x plus y equals 5. So I think I'm going to try to eliminate the x's. And to do that, I would have to multiply this bottom one. And I'm going to choose to multiply it by -3 rather than a +3. The reason I choose to multiply by a -3 is because that way I would have it the opposite, and it would be easy to add at that point. So I'd have for that one -3x minus 3y equals -15. And for the top one, I still have 3x plus 2y equals 10. Now I'm ready to add, and those are going to disappear because negative and a positive x of 3x are going to disappear. 2y minus 3y is going to give me a -1y, and that's going to equal, and remember this was a -15, that didn't come up, that's going to equal -5. Well, I don't want to know what negative y is, I want to know what positive y is. So if I divide this, basically both sides by -1, I end up with y equals 5. So in order to get my other one, I need to plug in the 5. So I plug it in here, or yeah, plug in the 5. So if I plug it in here, I would have x plus 5 equals 5, which if I solve that by subtracting 5, x is going to equal 0. So my solution should be 0, 5. And really, I should check that with Desmos to make sure I am good. Okay. Number 2, this one looks big and scary until you really look at it. And really, the first two already match. The x's already matched. So I'm going to make it easy and just add those together because one's positive and one's negative. So when I do that, 8y minus 6y, or plus -6y, ends up becoming 2y equals 4. So when I divide both sides by 2, y equals 2. So that was pretty easy, actually. Well, now we have to plug it in to come up with those values. So if I plug in the two, I guess I'll plug it into the top one. I have 4,781x plus 8 times 2, which is going to be 16, equals 16. Well, when I subtract 16 from both sides, I have 4,781x equals 0. Divide both sides by 4,781. Well, 0 divided by 4,781 means that x equals 0. So my solution would be 0, 2. Again, use Desmos to check yourself. All right, so 3 through 5, we're using now the substitution method. So substitution, I'm going to use the fact that this is already set, and I'm going to plug this in place of here. So 2, because there's 2y, and I'm going to plug in the 2x plus 3, and then that equals 4x plus 6. So if I distribute and simplify, I end up with 4x plus 6 equals 4x plus 6. And really, I should recognize that's the same thing on both sides. So if I were to subtract off and the x's and move them to one side, I'd end up with 0 equals 0 or 6 equals 6, which is a true statement. So that means if it's true on both sides like that, or 6 equals 6, or whatever the case may be, we have infinitely many solutions. Okay, so my solution would be infinitely many solutions because that is the same line. All right, so the next one, I'm going to use the fact that y equals this and plug it in place of that. So I've got 3x, because that's my top, so I'm bringing that down. So 3x plus 2 times the y, which I'm not going to put y anymore. I'm going to put the x plus 8. And that equals the 96. Okay, I have 3x plus, and I'm going to distribute 2x plus 16 equals 96. Or 5x plus 16 equals 96. And if I subtract 16 from both sides, 5x will equal 80. And then when I solve by dividing by 5, x will equal 16. So if x is 16, I'm going to plug it back into here because that'll make it easier. I can plug it into either one, but this one makes it easy because then I just have 16 plus 8, which is 24. So y is going to equal 24. So my solution for this one would be 16, 24. Again, it's always good to check yourself via Desmos because we have it, so let's use it. All right, both of these are y, which means that I could take this because that's what y equals, and I can plug it in place here. So really what I have is 15x plus 4 is going to equal the 5x plus 34. So now I'm just going to solve that by subtracting 5x on both sides. So 10x plus 4 equals 34. When I subtract 4 on both sides, I have 10x equals 30. And then when I divide by 10 on both sides, I'm running out of room, x equals 3. Okay, if x equals 3, all I have to do is plug it into one of them. Doesn't matter which one. I'm going to go ahead and plug in just the top one. 3 times 15 is 45, plus 4 gives me 49. So y equals 49. So my solution for number 5 would be 349. Again, check yourself using Desmos, and my parentheses got hidden there. Okay, check yourself. All right, solve using any method. You know, if you have the opportunity to use any method, my suggestion would be use Desmos. Okay, you can use one of the others, but definitely you should be using Desmos to check yourself for sure. So for the first one, we have y equals negative 2x minus 4 and y equals x plus 5. So if we type those into Desmos, here's what we have. And we can figure out that our solution is going to be negative 3, 2. Okay, so negative 3, 2. All right, so the next one, we have 5x plus the 1.7y equals 25, and 1.7y plus 3x equals the, or 1.7y plus 3x, or equals 3x minus 15. When we plug that one into Desmos, both of those, we find that they intersect at the point of 5, 0. So our solution would be 5, 0 for that second one. All right, the third one, x minus 2y equals 3, 2x minus 4y equals 6. And when we type those in, we find out that they are the same line. And so when they are the same line like that, we can show that they're the same. Okay, take that off and see. So that we would have infinitely many solutions for that. So infinitely many solutions. And if they were parallel, that's where we would write in no solution. Okay, so infinitely many solutions. And finally, the last one, the 2x plus 3y equals 6 and 2x equals 18 plus 2y. I'll jump over back here. And we have an intersection at the point of 6.6 and negative 2.4. Okay. So 6.6 and negative 2.4. All right. So when we can choose, that's what I would do. All right. So number 10, we are Circling the ordered pairs, there are solutions to the following system of inequalities. So first thing we have to do is graph those, and then I would graph the points. I'm going to choose to do so with a table. So when I do that, here's what I have. Okay, so I have my two inequalities. We have the red, we have the blue, and all of the different points there. If we take a look, this one doesn't work. This one definitely doesn't work. These don't work. This one could if it was just for the red one. This one, because it's a dotted, does not work. So really the only one that's going to work is the 4, 6. All the rest of them, this one, if this were a solid line, we could use that. But being it's a dotted line, we can't use that. So the only one that's going to work in this case is 4, 6. All right, I'm going to do part 2 for the back side.